Hello and welcome to part 4 of Dev Maths and Stats Refresher Course Lecture 8. Now in the next two videos we're going to look at some demonstrations, and I would really encourage you to make sure you have downloaded this spreadsheet. It's the spreadsheet var covar, which is available along with these notes, and make sure you're on the page here, you're trying this for yourself, because the whole point of this is for you to get a feel of how these parameters change the distribution of numbers, the way they interact, and the summary statistics we get from it. Because for a lot of the rest of the course, you're just going to read these things mentioned, and you just have to take it for granted. You haven't got a chance to see how the actual numbers are changing. So please take the chance now. And what we're going to try and do is to get as an output from this these rules here. I think this one we've already got. The rest will be new rules, but they're rules that you'll see all the time in econometric and statistical theory. But as well as just getting the rules, it's the idea to see how these kind of abstract things relate to actual data. So what I've done is I've got it set up on a spreadsheet, and I've just transferred these across so you don't have to keep flipping backwards and forwards. If this text is too small, then maybe you can just look at the original version. So what we've got here is a discrete random variable which can take these values 0 to 50, and these are the probabilities of each value as before, and this is what's called the cumulative probability. Just thinking I'm going to just expand it a little bit, like so. So values of x, these are the probability of x, cumulative probability, which just means, as I said in a previous lecture, the probability of getting that value or less. So if you look at this one here, this 0.5 is where it's actually here is the probability of getting less than that. So probability of getting, and you can see it's all the probabilities added up before that point. So the probability of getting 50 is 0.3. Probability of getting less than 50 is all these added up here. So eventually, if I kept going for another 1, it would be equal to 1. And so the probability of getting less than 50 is 0.95, plus the probability of getting 50 itself gives you 1. So that's cumulative. Okay, so what we're going to do is we need to, actually, first note what this is. This is just showing a diagrammatic representation of the probabilities over here as a histogram, just so you can get an idea of the distribution of that probability. Okay, so add column XP. Like so. I'm putting capital X there, just to be consistent. So add in the column XP, and then we're going to equals X times the probability. So that's the value of X times the probability. So we multiply that all the way down to here, and so on. So you should be getting familiar by now with what this means. The value of each X value times the probability for that X value, and then add that all up, is giving you the expected value. So there's expected value, mu. So mu is 24. Okay. Then add columns like this. So x minus mu to the power of 2. Let's calculate that. This one is going to be equal to the value of x, in brackets, the value of x, subtract the expected value of x, but I can't just leave it at that because I want to copy this in a minute down here. As I copy the formula down, I want this to move down. So this one's this one's this one's this one. But every single time I want to make sure this stays. So I'm going to make sure that's fixed there just by fixing the column number, the column, so F. So make sure there's a dollar in front of the F. Make it d to the power of 2. So 576 is 0 minus this squared. Then when I copy this down to here, I should find it in the other ones, like for example here, it's taken this. Okay, deliberate mistake, fine. Don't want to fix the column at all. I need to fix the row. Like that. How many people saw that coming? That's better. So when you get down to here, this is then fixed. And then I'm going to put in this. Oh, look, put it up to 3. See, it does tend to increase numbers when you drag it along. Times p. So that's the value we got times the probability. And if you multiply values by probabilities and then sum them, that's the sum. If you multiply this expression by the probability, what you're getting is the expected value of this expression, as always. So that's the expected value of that expression, which is by definition the variance. So sum the last column to find variance of x. Okay, before we carry on, and this is where I hope that you are actually having a go at this yourself. What I want you to do now is to, if you change the probability distribution, how would you change this probability distribution to increase the variance? So if you can do that just by changing these numbers. Remember that they should always add up to 1. What I recommend you do, if you leave that one alone, don't change that one, and then it'll automatically adjust when you change the others. So if I increase this thing a bit here in the middle, so I made that 0.28. Yeah, then this will decrease down to make sure it adds up to 1. But unfortunately, that did not increase the variance. That's how you decrease the variance. So try it yourself. To stop the video, change these numbers a bit, and see if you can increase and decrease var x. And watch what's happening over here, because that gives you a clue. Okay, I hope you tried that, because I'm now going to show you how I would try and do it. To increase it, I'd want to put a bit more out here. Oops. And a bit less in the middle. And get a bit more out here. Oops, that's too much. That's not bad. So you can see it's become more spread out, and the variance, oh, it has got that much there. Sure, I could do better than that. Actually, what it's down here. I want to get rid of some of that. Yeah, that's better. That's really increased the variance a lot, to really spread out the probability distribution. So that's how you make it bigger. If you want to make it smaller, you just really shrink these away to nothing at the ends. It's too much. No. So that's greatly reduced it, because it's really concentrated in one place. So it's the probability distribution controls the spread of the variable, which controls the variance. So here it's really concentrated, or we can really spread out, or we can go back to where it was to start with. So I just have to keep pressing undo until I get to that. Hopefully those are the original numbers. Yeah, okay. So done that, carry on. So if you're doing this at home, or wherever you are, I hope that you have reset this before you continue. Otherwise the whole thing will, or the rest of it will be different from my results. Okay, now we're going to move this right out of the way. There somewhere. Oh dear. And this is the part that people sometimes go wrong. What I want to do is copy the whole table, so I've got a second version starting from column J. Let's get the whole thing and start from there. Control C, copy that whole thing there and stick it over here. So it goes off the screen a little bit, that's not too bad. Okay. Okay, modify the copy so that values of random variable y are given by ax plus b, where a and b can be changed. So this is then going to be x, and this over here I want to call actually y. So what I can do here is just change the p's to y's. Okay, that was a bad move. As I said, what I can do is, I'll give me the idea of changing the p's into y's. Change the x's into y's would be better. So here we have the table for random variable y, but you want to make sure that y depends on x. So y should be given by ax plus b. So I need some parameters here. So let's have parameter a and parameter b. And let's have parameter a starts as 1 and parameter b starts as 0. And instead of these values of y here, I want these to be equal to a, and that needs to be fixed, times x plus b. So the formula is that y is equal to a times x plus b for all values of y. So even this one. Now, at the moment, we've got a situation where y is equal to x because of 1, 0. But if I put a as 2, then y would then be 2x. If I put 3 here, then y would be equal to 2x plus 3. So I've made y into a linear transformation of x, and now all I want to do is to note what happens to ex and varx and try and compete the rules which you've got above. And we can get all those rules, which I've pasted in, well, they're in here. So you should be able to work out all of these rules just from varying a and b and see what happens. So I'll go through it slowly, but I'd recommend that as you get the idea, you stop it and try and fill in the rules yourself and see how you can get that from the spreadsheet. So stop it for a second, and then I'll carry on to show you the first one, and so on. So the first one it asks you about is what's the expected value of x plus b, where b is a constant? So to do that, you want to add on numbers here. So if I put 5, then y is equal to x plus 5. But what's happened to the expected value, where it's gone from 24 up to 29, so it's just added on the 5. You can verify that with, maybe if you took a number off, took away 3, that goes down by 3. So that's a fairly unsurprising result, that whatever you put in here, that changes the expected value by that result, by that amount. So going back to here, we're going to record the answers. This just means that this is the expected value of x plus b. Okay, next one is see if you can verify the rule you've already got, which is that this should be a times the expected value of x. Go back to the spreadsheet, see if you can work out how you do that, and I will show you. So hopefully you have paused that. All this is asking you to do is to multiply, put in the multiplication factor here, 5. So 5 times 24 is 120. 10 times 24 is 240. So when you multiply y by a factor, the expected value multiplied by the same factor. Surprise, surprise. And if it's negative, it still works. So that's one we already had, which is that this comes out as a e to the x. The expected value of just a constant, go and try that. You know it should be, well, it should be here. So to do that, you would just clear that to 0, so y is nothing, and then just put any constant number in, so 46. So the expected value of 46 is 46. Great. So there we go. So the expected value of b is just b. Now we look at some variances. Oh, I knew there was a mistake. How annoying. I always get this far and somebody in the live lecture says, oh, that should be just small b. And then I forget. And then the next year someone tells me the same. So that's bar x plus small b, where b is a constant. So it's kind of going back through the same ones we've just done, but looking at the variance. So if you just did the same things we just did, and look at what happens to the variance. So the first one, hopefully you've paused it and done it. So that's when you have 1 there, maybe it's a number like 5 or something here. So this is y plus 5. Now we saw the expected value goes up by 5, but the variance has stayed the same. And hopefully you can see why it is that the variance has stayed the same. I mean, if you think of it in terms of this spread, it's moving it up by 5, but the spread is not affected. So add something on. Adding something on doesn't affect the spread at all. So var of x plus b would just be var of x. So the small b constant just disappears. It's not there at all. Okay, what about like this one here, when you multiply by a fixed number? So try multiplying y by a fixed number, changing a. Can you see what happens to the variance? Okay, hopefully you've paused that and tried it. So if I put in 5 here, you can see that the expected value has multiplied by 5, but the variance, this is not multiplied by 5. In actual fact, oops, you can get a clue by dividing this by the original variance. Okay. This divided by the original variance, 25. So this has gone up by a factor of 25, which may be a clue because I multiplied by 5. If I double it, so y is 2x, the expected value of 2x is 4 times, so the variance is increased by a factor of 4. So it's increasing by the square. So this can trip you up if you are looking at this in a book, trying to follow something or demonstrate something. You don't realise that when you take the a outside, it becomes a squared. Okay, so that's probably the hardest one. Var ax is a squared var x. This is probably the easiest one. What's the variance of a fixed number? Just try it out. Hopefully you can see what it's going to be. What's the variance of 42, for example? 42 will never change. The variance is 0, because 42 is 42 is 42. Expected value is 42. The variance is nothing, because it's not random. Okay, so I think now we've got all these rules. Yeah, good. So we completed these rules for a random variable. And next we go on to look at connections between the equivalent ones for two random variables and how they're connected. But for now, thanks for watching.